A brief bio of Rosaria. Rosaria received the master's degree and the PhD student in the computer science department at the University of Turin. And she currently works as the senior researcher in the IoT and pervasive technologies research area in Links Foundation. And she has been involved in several international projects financed by the European Community and also regional projects. Her research interests include also the machine learning and the deep learning techniques applied to the Internet of Things. So, Rosaria, if you want, you can start with your presentation.
Thank you, Ilaria. Today we will talk about REPLICA. But first, nowadays, digitalization, productivity, environmental impact are key points of the optimization for the industry. Improving optimization means improving competitiveness. So, what is the solution of a good optimization? The solution is the technology. Technology is advancing fast and helping industries to obtain more and more detailed data. An example of these are artificial intelligence, industrial Internet of Things, digital twins, and so on and so forth. In fact, the possibility to monitor and control each part of the process is a strong base on which we can build a more intelligent and focused control. The technology advance brings innovation and possibility to manage the production in terms of near future through artificial intelligence prediction and decision-making support. As a result, forecasting demand and production, optimizing process by reducing cost and improving efficiency without corrupting the quality of the product is a big challenge for industry. And this challenge has been accepted by Reclaim. Reclaim is an European project that has started in 2019. Its objectives, very high-level objectives, are application of big data analysis techniques, predictive analytics, and model-based forecasts and optimization procedures based on completely data-driven process. Increase flexibility in changing machine operation purposes, and remanufacturing of the machine. In this context is born REPLICA. REPLICA is the Reclaim optimization and simulation cooperation in digital twin. The aim of REPLICA is the creation of a digital twin of the factory environment to be used to monitor and predict the performance and the status of the factory asset. REPLICA has a very clear objectives that are the simulation and the optimization of the process, the support of the digital retrofitting based on the real data simulation. They introduce and enhance the smartness of each machinery in the plant or the machinery that needs to be enhanced. And deploy our digital retrofitting infrastructure, provide a flexible, scalable architecture for intelligent digital twin, and provide a full diagnosis and predictive maintenance tool. Here we can see the architecture of REPLICA. As the figures show, we have two main blocks. Sorry, a back-end and a front-end block. In the back-end block, we have the core of REPLICA that consists in three main components. The artificial intelligence environment that hosts the AI modules and the AI engine. The digital twin orchestrator that orchestrates all the operation done by REPLICA. And the simulation environment in which we have a distributed environment that includes several heterogeneous simulators for deployed in different machines and for different parallel simulation. The front-end application contains two different user graphical interface. That is the output monitoring for the application devoted to show what is the results of REPLICA, obtained by REPLICA. And the second one is the configuration. It's an application used to configure the data of the component, inside the component. REPLICA has some technology, use some technology, and here we can see some overview of this technology. And we have, for example, Docker, that is the basic technology used to increase the portability and the interoperability of heterogeneous components. Kubernetes for the easy deployment and the orchestration of the AI modules and simulators. MQTT and XMPP that guarantees standard, scalable security communication channel among the components. We have CP-Swarm simulation and optimization environment that has been as the base for the DTO and the simulation environment. We use Dinosaur that is used for build the full diagnosis predictive maintenance solution, and Jupyter, Akumus, and Thingsboard are other solutions that are under evaluation for the for the development of the AI engine and the graphical user interface. We try to have an hypothetical use case on Replica. And in this case, we have two scenarios. One is the deployment in the industrial side, in which the objective is simplify the development and deployment of a full diagnosis and predictive maintenance solution based on digital twin. The advantage that Replica brings is a rapid customization to the present infrastructure, allowing the integration of already available IoT sensor models and new and present AI algorithms. And also as a flexible deployment, adaptable to specific needs. In the second scenario, we have a replacement of a machine in a shop floor. The objective is simplify the adaptation to change in the physical environment. Replica can bring advantages that are rapid replacement of the current component to adapt and to change the environment at runtime, an intuitive interface to recreate the environment that we have there. We jump to the conclusion that is that current innovation technology allow implementing advanced fault diagnosis and predictive maintenance technique based on digital twin. Replica provides an architecture that can be customized in different scenarios to ease the development and deployment of such solution. The solution combines open source software that we saw in the previous slide with modules that will be deployed ad hoc during the Reclaim project. Replica will provide advantages in different industrial use cases and domain from the development of full diagnosis and predictive maintenance mechanisms in industrial side, in their adaptation to the change in the shop floor. I'm thanking you for the attention, and I'm here for questions if you have some.
Okay, thank you so much, Rosaria. Very interesting paper. If the participant have some question, or I have a question for you.
Okay.
You explained that this paper present the predictive maintenance and the fault diagnosis approaches with the digital twin concept and the combinations of the industry and the IoT. And you also mentioned that Replica have some tools that has been implemented in previous projects or so on, and other are being studied, are proof of concept. No? As a future development of this tool or this project, what are the possible real scenarios, or how will Replica be tested and deployed in real scenario, in real smart manufacturing scenario?
Okay, yes, that's true, all that you said. And yes, we will have a deployment in a real scenario. And in the project, we have 5 pilots. I think these 5 pilots have different domains, and it will be tested in several of them, probably in the wood manufacturing and in the textile industries.
Okay, so, okay, perfect. And in the last slide, in the conclusion part, you talk about the open source software that do you think that this could be a best practice, a good point in order to collect the data from the industry, or not? So to elaborate this kind of data is a good approach to use this kind of open source software, or the companies are not permitted to have this kind of data? What do you think about the possibility to use the open source in this kind of projects, or in the industry IoT?
This is a very interesting question, actually, that brings us to several answers. I think that mostly depends on the industry and the open mind that they have. Open source doesn't mean not secure, or doesn't mean doesn't work. So you have, of course, to know how to make it work. And maybe this is the problem in industry, because if you buy a solution from a private organization, like, for example, you buy a solution that is Microsoft solution, it's all I install that and that's it. For the open source, it's different. We build the solution, but it's always in, let's say, it can be always transformed, and it can be customized. That is one of the key points of the open source solution. So you can really have something that you need, and you can create what you need. But this is also a problem in if we think about what we already have in the industry, because sometimes you have to merge open source solution with we call private solution, but it's not like that. But if you have, for example, some machines that support only that standards, for example, only that brand, you are forced and obliged to use that brand. So maybe the answer is a mix for now of these two, let's say, approaches.
Okay. Also this part could be studied in this project. Okay, perfect. Okay, if we don't have any other question from the participant, we can move to the other paper, that is semantic models for network intrusion detection.